tell you about black holes. So first, I want everyone to close your eyes. And as you close your eyes, imagine the fastest things possible. A cheetah, maybe Usain Bolt. Now imagine you, and now think about light. And that's one of the fastest things in the universe. So imagine that light can't even outrun a black hole and escape it. So basically, a black hole is a place secluded from the rest of the universe that you cannot escape. So open your eyes. And now I'm going to explain how they work. So I hope to increase your vernacular in astrophysics through 3 key theories that can explain black holes. I was a NASA aerospace scholar, and I've been researching into black holes since the 5th grade. So we're going to see about the nature of space. Now, as you can see, everybody tends to think of space as flat. Now, what Einstein did for us is he changed that with general relativity. So if you imagine that this apple was maybe the sun, and it bends space like this, so you can see that it's bent. And so if this marble was the Earth, when you go around it, I threw it too hard. When you go around it, when you put it in there, it ends up orbiting around the apple. So after class, I invite you to come by and play with it with yourself, and maybe not destroy more than one world. And so what a black hole would look like, instead of being like just, the mass of the sun, they could be even 5 times more than the mass of the sun. And what a black hole would look like would be like this. And so when you have a star falling into a black hole, it orbits around it. It orbits around and kaplunk, right? And that star is not going to get out of that black hole. So what bends space this far? And what it's called is a singularity. And so basically what happens is I take something the size of this apple and you smush it down to the size of a marble. So that's basically a metaphor. That's what happens when a star bigger than our sun goes supernova. The inward forces collapse it, and that's why you get something like this that bends space like this. And so now we've learned about general relativity. I'm going to take you into the fun part of black holes. Death by black hole. According to Neil deGrasse Tyson, let there be no doubt, there's no more spectacular way to die in space than death by black hole. So there's 2 main theories of how you would die in a black hole. One is called spaghettification. And so basically, that's a fun word that astrophysicists like to use. You're the person, right? You fall in the black hole, and as you get closer to the singularity, you end up being stretched out like a piece of spaghetti. And that's because the tidal forces at your feet are greater than the tidal forces at your head, so you end up being pulled apart. The second theory is much less fun, and that is called firewall theory. If anybody's familiar with computers, it's the same kind of idea. It keeps stuff out. You go in the black hole and you're immediately incinerated. And the reason that happens is because stuff being trapped inside the black hole, because we can never lose information, builds up over time, and there's lots of heat, and that heat just poof, turns you into sand. And so another thing to talk about black holes that's extremely interesting is called about time. And here's 2 things that happen when you a black hole, again, because of how we curve space. When you curve space, you're also bending time, because space and time is a fabric that goes together. And so if you understand this, you can understand what happens to time around a black hole, and 2 things happen to time around a black hole. Number 1, as you go into a black hole, because time is bent, and it's actually bent in 3 dimensions instead of just 2, so it's more like a bubble. But as you go in the black hole, after you cross the event horizon, the past, present, and future all happen at the same time. So basically it becomes unstuck in time is what they believe. Another phenomenon about black holes is when you go, if I was an astronaut and I said, hey, you know what? I want to live to be in Star Trek, but I'm gonna be like 100 and probably die before that happens. Well, I mean, if I took my little spaceship, like out and just sat around a black hole and orbited around it for a long time, basically what that's gonna do is that's gonna slow down time for me, but it's still gonna go fast. Back here on Earth is gonna go normal speed because you're not experiencing that gravity well, like Earth has been space this much. Black holes like, see, so. You're not in that gravity well, so basically, after I orbit around this black hole for what's like 2 years for me, I come back a couple centuries have passed on Earth, and then I get to be a captain on Star Trek. So, yay! And there's one more thing I'd like to share about black holes. Oh, I forgot my quote. Interstellar. I'm an old physicist. I'm not afraid of death. I'm afraid of time. Okay. And last but not least is how information. So Leonard Susskind and Stephen Hawking got in basically a huge war over this. Stephen Hawking says once something's in a black hole, it's gone from the universe. You lose that information. Like the conservation of energy, you cannot destroy information. So, political disclaimer, I'm a cheerful independent, but I gotta use Hillary's emails as an example. So we took some emails from Hillary Clinton, and she stuffs them and deletes them. First it starts out like this, and then she stuffs them and deletes them. What happens is as you put more emails, and as you delete more emails, it would increase in surface area. So if our emails were a black hole, it would go from this to this. And then over time, it would evaporate. And then it would go back to this. So that's how information isn't lost. It's radiated as heat back out into the universe. So basically, I'm going to end with this. It's very possible, according to these three theories, that we actually live inside a black hole. And there's proof for this because the singularity I showed you is the same singularity they talk about when scientists talk about the Big Bang. So they talk about an infinitely dense and hot point exploding into the universe. Well, that's exactly what happens inside a black hole. So I'll leave you with that thought proclamation, and thank you. Hopefully you found something interesting to learn.